now that you've had quite a bit of experience working with inverses and functions, all right, we're going to talk about how to prove that two functions are inverses of each other. Right? And so what's going to happen is you're going to be given two functions, and you're going to be asked to prove whether they are inverses of each other or not. Right? And the big thing that we need to know is this. Right? So let's say we're talking about functions f and function f and function g. Right? Well, if f and g are inverses of each other, then two things must be true. F of g of x has to be x, and g of f of x has to be x. All right? So let me kind of talk real quick about what these two things mean. Right? F of g of x is equal to x, g of f of x is equal to x. Right? What does that mean? Right? What that really means is that this is the mathematical way to show that f and g undo each other. Right? So in other words, if you plug something into g, you get that output, and then you were to plug that into f, right? Then you should get some output, and it's going to be x. It's going to be what you started with if f and g are truly inverses. Right? Let me give you a number example so that you can see. Right? So right here, this is saying start with compute g of x, and then take that and compute f, right? Or in other words, I'm going to take some input and put that into g, and then that's going to give me some output, and then I'm going to put that into f, right? So what this is saying is that if f and g are truly inverses of each other, they should undo each other, right? So in other words, if I were to plug in, let's just choose any number, let's say 5 into g, well, that would give me some output. I'm just going to call that g of 5. Right? And if I were to take that output and plug that into f, well, if f is truly the inverse function of g, then the output here, should get me back to 5, because it undid what g did. Okay? And also, it should work the other way around, right? So this one, right? This is saying start with f, compute this output, and then that goes into g, right? And that should give me x, right? So in other words, if I were to plug something into f, and then take that output and plug that into g, this should also work. In other words, if I plugged in 5 into f, well, that's going to give me some output f of 5. And then if I take that and plug that into g, then that should give me 5 if f and g are truly inverses of each other. Okay? All right? But it's not enough just to test it out with a number like 5. Right? What this is really saying is that to prove f and g are inverses of each other, you have to show that this is going to work for any number you pick. So in other words, you are going to do two things. You're going to show me that f of g of x is equal to x, and g of f of x is equal to x, right? So for this one, right, we're starting with g and then plugging something into f. You need to show me that if you plug x into g, right, and you get whatever output, let's call that g of x, and you plug that into f, you should end up with what you started with, x, right? And same thing if we did it backwards, right? If you plug x into f and you get some output, and you take that, plug that into g, you should get back to x. Okay? So all we're saying is that this is the mathematical way to prove that g and f undo each other. You have to test this and show that that's equal to x, and you have to test this and show that this is equal to x. All right? Let me do an example for you. All right, so let's determine, or in other words, let's prove whether this function f and this function g are inverses of each other. Let's check that, right? And remember, there's two things we have to check. Okay? So the first thing we need to check is we need to check f of g of x, right? And if this comes out to be x, right, then we're in good shape. Okay? So this is saying let's plug g into f, right? F says let's do 2 times our input minus 7. So that's what we're going to do. 2 times our input minus 7, right? And what am I going to input in there? I'm going to input my g of x, right? G of x was this. right? So I'm going to input x plus 7 over 2, right? And let's see what happens when I calculate this. Right? Let's see. Well, right here, this 2 and this 2, they're going to divide out. 2 divided by 2 is 1. So I'm just left with x plus 7 minus 7. And now you can see really easily, x plus 7 minus 7, that just ends up as x. Okay? And that's what we wanted. Okay? So, but we're only halfway there. We also have to show that it works the other way around. We have to show that g of f of x is also x, right? So let's do it the other way around. So this is saying I'm taking the output of f and plugging that into g, right? So g says I'm going to take my input, add 7 to it, and then divide that by 2, right? But what am I going to plug in for this x? Right? Well, that was my input here, f of x, which is this. Okay, so I'm going to plug in 2x minus 7, and let's see what happens. Right? Well, if I simplify the top, 2x minus 7 plus 7, that just gets me 2x. And then now I need to divide that by 2. And we have successfully shown 2x divided by 2, that's x. Okay? And so you can see we have proven that f of g of x equals x, and that g of f of x is also x. Right? And what that really does is we have mathematically proven that f and g undo each other, right? So now our conclusion is that f and g are inverses of each other. Okay, that's our final answer. Okay, so again, you have to prove that both of these work, right, to show that they're inverses. Okay, all right, lastly, I want you to check to see if h and j are inverses of each other. And you're going to do this on your own. You're going to try this on your own, and we will check this in class. Okay? So it works the same if I called f and g or h and j. You got to test two things. You need to test h of j of x, and you also need to test j of h of x. Okay? And if you can successfully prove that this is equal to x, and that this is equal to x, you have successfully proven that h and j are inverses of each other. Okay, so that's what I would like you to do, and we will check that off in class tomorrow.